So thanks everybody for joining the May edition of the Higher Education Power BI user group. I'm Jeff Cook, one of the co-organizers of the group here. We have Pete Bembo, and I think is James on? I haven't seen him join here, but James Bartlett is one of our other organizers as well. So thank you all for joining. We have a pretty nice agenda here today. We had some, as usual, some updates we wanted to share with you, but first things first, let's go over the mission of the group for those that may be new to the group, or just a reminder for those that have been here before. Our mission is to train, educate, and connect data professionals who work with Microsoft Power BI at colleges and universities. Anecdotally, I will say that I think more and more colleges and universities are transitioning to Power BI from their different platforms. And so that's a really important thing to bring up because today's speaker is going to be talking about some of that and their transition from Tableau to Power BI. And as somebody who transitioned from Tableau as their primary enterprise reporting software to Power BI, I think this is going to be a great presentation for everybody. Another reminder here, so we have a Slack channel. Please make sure to join the Slack channel if you can. Right now, we don't have too many people in there, and we'd love to get the conversation going outside of these monthly user groups. It would be great if we could get on there, share some of our best practices or some of our struggles. Everybody in this community is always willing to lend a helping hand and answer some of those questions. So get in the Slack and let's get engaged. All right, so as usual, let's go through some of the new features. Everybody loves the new stuff, right? So this month, the Power BI service and Power BI desktop came out with a couple new features that at least I'm excited for. I love the data visualization and the customization features that they've been coming out with recently. In particular, this month we see some formatting updates here. So modern tooltips has now become the default. So this is something that I've always had checkbox. I don't know if this is good or bad, but typically whenever there's a preview feature, I will go into options and check that box for the preview because I love testing out some of those new previews there. So this is something that has always been default for me, I think essentially, but this is now the default that you'll see here. And if you read some more about this, in the coming months, Power BI or Microsoft has announced that some of the tooltips will become more and more customizable. So again, if you've come from say Tableau, where those tooltips can be really, you can put anything you want in there, you're going to see some more customization coming from Power BI on that side. Also, matrix layouts. So I've added the image here on the slide. Anybody who's done pivot tables in Excel, which I'm probably willing to bet is every single person that's attending here, you'll notice that if you hover over here, you can see the options in the pivot tables in Excel, show in compact form, outline, tabular. Some of those options have now come to the matrix style visual in the May 2024 release in Power BI. So test that out. I know that was something that everybody's familiar with pivot tables. It's something that some of our users have been asking for. So now this is going to be available in the May 24 release. Once you get that, line updates, some more customization with lines. I can't go wrong with that. And then on object interaction updates. So some of the visuals that you can see in Power BI, you can edit some more on that object. So you double click in there, you can add some customization, different titles, and things of that nature. So some of those updates are there. Another feature that came out this month, or will be coming out for some of you, is the publish to folders. This is in preview. It's not in GA yet, but we haven't taken advantage of some of the folder functionality within our Power BI workspaces. However, we do plan to. So if this is something that you've done and you've wondered, hey, why can't I publish directly to that folder? I have to publish to the workspace and then move. Well, this is now available within public Power BI desktop. You can publish directly to the specific folders, which is going to do wonders for some of the organization there for some of you. And then DAX query view. This is available in GA. So also Copilot to write and explain DAX in DAX query view. That's in preview. That's something, as more and more organizations, especially Microsoft, lean into AI, Gen AI. This is going to be here for a long time, so let's get used to it. Let's use it to our advantage. So this is something that if you have, I think there's a limitation based on the subscription you have, of course, with using Copilot, but if you have a Fabric capacity or premium capacity, I believe you'll be able to use this to help write DAX for you. So depending on your expertise, DAX comes easy for some, DAX comes difficult for others. And I'm one of those in the latter box there. Copilot can help explain and help write DAX for you. So that'll be a really great thing for you. So that's the Power BI service, some of the updates for May 2024. And here are the big updates. I'm being facetious here. Power BI report server. So according to the website, the latest version was February 24. And I haven't heard anything since. I don't know if you've heard anything, Pete, but it seems, as Pete has said, I think on pretty much every user group, the Power BI report server is on premises, is being slowly but surely phased out in favor for the cloud service. So not really anything to report here, but kept this in here for posterity. Anything you want to add there, Pete? I saw you went off mute.
Nope, spot on. Still, I mean, I expect that they'll do a release for report server any day now, and it will probably have like a couple of minor things in it. But yeah, they're letting the report server die a very slow death.
Yeah. So there's that, and then some announcements. So this is pretty fun. As of this morning, or maybe late last night, we actually have 600 members in the group. I checked this earlier this morning. We are at 500. We passed the 500 threshold last month, so now we're at 600. So that's a really good thing. We're growing, and we keep growing because of that interest in the tool. Another thing that I think is really important is the survey that we launched on May 10th. Be sure to fill this out. The next slide is going to have the link to it. So please make sure that, write that link down. Please, somebody put it in the chat, whatever it may be. Go in and fill that out. This survey, just to give you a little more context of what it's being used for, is to really understand our user group better. Who's in it, what level of expertise you have, what content you'd like to see as part of these user groups, and the cadence, right? So there's more questions in there, but please make sure to fill that out. That way we get your feedback. One of the questions that, just to share some of the results we've seen so far, one of the questions that I've been most surprised with was the question around where do you primarily source your data? The majority of the respondents reported that they get it from flat files that are from disparate systems, not necessarily a data warehouse or a data lake or things like that. So that gives us context about what type of content to offer you all that would be relevant. So please make sure that your voice is heard. Go in and fill that survey out. All right. So the next month, little preview here, we're going to talk about next month's Data Dojo, which is going to be presented by James Bartlett, one of our co-organizers. The Data Dojo is the Power BI community practice at Des Moines University in Iowa. So just to repeat some of the content that you'll hear next month, you're going to hear about the Data Dojo's egalitarian founding principles and its unconventional structures. Some of the topics that they've covered in their workshops, what's gone right and what could have done better. So I think it's important, if you're interested in developing sort of a community of practice at your university or across different universities, I think James has already solved that puzzle, so to speak. I don't want to speak for him, but he's done a lot of that work. So please come to the next meeting to understand sort of the ins and outs and some of the pitfalls to avoid and what to do to really develop an effective community of practice for Power BI. Okay. Oh, also, James is a Microsoft MVP, so he's got some clout behind him. So make sure you come, and he's like a local celebrity, right? So that's going to be July 17th. So I know, once summer hits, a lot of folks potentially could go on vacation and things like that, but which is understandable. Please make sure if you're available, go ahead and join. Next slide. So please, here is the form, the link to the survey, which is a Microsoft form to fill out. So if you want to, you can scan it via your phone if you'd like to scan that QR code, or also put this link right here. If somebody could put it in the chat, that would be great too. And I can also put it in the chat once I'm done presenting here. Okay. And as always, after the meeting, look out for emails containing links to our YouTube channel. So if you don't know, we have a YouTube channel. All of the recordings from our previous sessions go on that YouTube channel. So that way, if you can't make it, feel free to go to that YouTube channel and just watch those there. Again, our Slack workspace, the link will be in the email following this meeting. Please go into there. No pressure. Obviously, if you're familiar with Slack or Teams, they function very similarly. Let's engage in conversations offline. Submit an idea for a topic or speaker. We're always willing to accept any type of content related to Power BI, and this is where that survey comes into play too, because this will help us curate the content and what's presented to you as well. And then volunteer to speak at upcoming meetings. If you're doing something that's cool or you find exciting, or even if you don't think it's exciting and somebody recommends that you present it, please volunteer. We're always looking for volunteers to speak at these types of meetings, and we have some lined up, which I think will be exciting for everyone, but we could always use some more volunteers. And then RSVP for our next meeting, which is going to be June 20th. Did I put that wrong on the previous slide? That's July meetup. Sorry, June 20th. Sorry, I got ahead of myself there. June 20th is going to be the next meeting. So please make sure you RSVP for that. So that way we have a brief overview of a head count. And that way we know what type of demand we're looking for. Okay. Now, let's talk about the presentation. So we have Zhen Zhang from the University of Georgia. And let me just give a brief bio for you, Zhen, before I hand it over to you and you can present some of your content. So Zhen Zhang is a data scientist at the University of Georgia's Office of Institutional Research and provides decision support for administrators, including projecting enrollment, predicting student outcomes, understanding student flows, and more. Prior to that, he held several staff positions at the University of Maine, working with graduate and international students. He has a BS in data science from the University of Maine at Augusta, an MBA from the University of Maine, and an AB in biology from Harvard University. All right, so Zen's going to present to us creating dynamic dashboards, parameters, measures, DAX, and how they differ from Tableau. This is something that I am, very fond of. I love Tableau, but I've had to start using Tableau or Power BI more, so I'm starting to love Power BI. And this is something that I think will be really relevant for a lot of folks on this call, especially me. So please make sure that we're going to have an open QA. You can raise your hand after the fact, but I'm going to go ahead and send this over to Zhen. Zhen, feel free to share your screen and start presenting your content.
Great. Thanks so much, Jeff. Let me share my screen. I just want to say a big thank you to the organizers, Pete, Jeff, James. I've gotten so much out of this, getting up to speed as we make this transition. So I super appreciate this community. And I got good feedback from my colleagues about this kind of work, some of these dashboards I put together. So I wanted to do my little part to give back. I hope that this helps you all as you transition and maybe gives you some ideas about how to use Power BI in a unique way. But just to kind of jump, let's see, I am sharing screen, right? Just want to make sure. Can everyone see me all? Can you see the screen?
Yes.
It's good to make sure. All right, so just a quick introduction about our office. We have kind of four main functions: data warehousing, internal, external reporting, and then data science. Oddly speaking, and as I mentioned, we're making that transition right now. I like to say that, we're beginning to consider transitioning. It's kind of that slow burn as we kind of phase out the old and bring in the new, and it's quite a lot to onboard. In terms of a data flow, though, we start from our systems of record, Banner and PeopleSoft primarily for us, bring that into our on-prem data warehouse. And then finally, we display using Tableau, Power BI primarily, and of course, Excel. That's always kind of an avenue. And then sort of data science sits somewhere in this space. So very much toward the end of this data flow. But basically what we do is we intake data from our data warehouse primarily, but also from source systems when we need it, and then try to deliver that information in a unique way using this dashboard. And so very much this sort of using Tableau in this final mile sort of methodology of data delivery. So I think what separates and makes our use case slightly different is that we get asked a lot of kind of what if style questions. So like, what if this happens? What if that happens? What if, the sky falls, or what if something wild happens? We try to figure out what to do. And when we hear these types of questions, the first thing we think of is to build a data model. And so data model is a word that's used quite a bit, but in kind of for today, what I'm talking about data model, I'm talking about kind of very simply just numbers describing some type of behavior or something system, right? And the system. And the reason why this is important is because you can kind of think of that model as some sort of math or calculator. That's why I like that image. And as you input data, you get a data out. But as you vary the input data, you get a variable output. And so that's kind of main concept that we have. And hopefully that calculator best represents some type of real behavior that happens at the university with students. And so today, my presentation is going to be centered around graduation rates, which I think this be something that is tangible. And again, I think that's something that's so wonderful about this group is that we have real higher ed use cases. And so hopefully this will be applicable in that way. And so to show and not tell, Today, I'm basically going to be walking through this sample dashboard. Everything here is fabricated data, but let me switch my screen to Power BI and kind of show you what we're working with. As a large public institution, our flagship, the University System of Georgia, we care a lot about residency. And so we have this dashboard divided into thirds. On the left-hand side is residents, right-hand side is non-residents, and then we have this kind of aggregate data in the middle. And if you look at this first third, you can kind of see that I have a histogram and we're predicting graduation rates. We got a predicted graduation rate. And then the kind of fun stuff, we got some sliders. And so as you move these things, everything kind of updates. Oh, I love this little gauge visual. I think it works well with this type of kind of data presentation. Not only can you slice, but you can also add, like, what if we gave someone scholarships? What if, right? And then you can kind of see the impact of that potentially happening. And as you do all these things, this moves and this moves. You can do the same thing on this side as well, slice at the same time. Maybe I want to compare only 3 O's on both in-state and out-of-state, right? Let's see how that looks, or maybe we can boost our out-of-state. You can kind of see this is hopefully is a little bit of playground. You got stuff to click on and kind of, you can interact with this sort of, this visual. And the funnest thing is that all the numbers update automatically. And so you get your answers right away. And so that's kind of the preview of what we're going to talk about. And I'm going to talk about each of these pieces and kind of build it from the ground up. So going back to the presentation, first thing I got to talk about is a little bit of the data model. Again, as I mentioned, that's super important to this whole thing. And so this sample data is a very simple data model. It's going to be a linear regression relating freshman GPA to a predicted graduation rate. And so we're doing linear regression, linear line. And so all it is a line of best fit. And so just to think back to middle school algebra, y equals mx plus p, still relevant. In our case, our y is chance of graduating, our x is freshman GPA, right? So you can imagine that's the inputs and the outputs, and we're making a little line, we're drawing it. And so then the m and the b, those are kind of numbers that we figure out. That's kind of the data scientist's job to try to extrapolate these numbers. In this case, since it's fabricated data, this model is 100% accurate. It's perfect. It fits the line perfectly for some, which obviously never happens. But in this case, I made it up. And so I put these numbers in. And so just to give an example, if we have a student with a 3.0 freshman GPA, then their calculated chance of graduating is 60% or 0.6, right? So pretty straightforward. If we were doing this in Tableau, this would probably come from the data source, as you can imagine, and then this would be a calculated field. And so one of the first things that kind of threw me for a loop is that there's not really a calculated field in Power BI, like you can't find those words. There actually are what I would consider 3 types of ways you can kind of create calculated fields. Hint, hint, measures is really the real calculated fields, right? That's if you want the Cliff Notes, that's kind of the overall thing. But at first, I think these 3 kind of symbols really represent the different data types. And I like to think of them as data shapes in Power BI. And so this kind of, when I was first starting out, this also kind of confused me because in Tableau, it's a little bit more hand-holdy. There's a lot more restrictions in terms of what kind of data structures you can use. But in Power BI, really the world is your oyster. And so first things first, measures generally create single values, kind of point values, also called scalars. I have a little star here within the given filter context, right? You can slice it up if you want to make a column. But generally speaking, kind of think about it as a kind of single values. Columns create one-dimensional columns, right? That vertical shape. And then tables are the full-on 2D tables. And again, this gives us so much flexibility, but I didn't pick up on this for a little while. I had a lot of struggles when I was working with DAX. Second thing that's unique is that measures react to parameters, and parameters are the same terminology if you're coming from Tableau. So they do adjust to things. And so just a hint, that scholarship slider, that was a parameter. And so it reacts to measures. However, new columns and new tables do not. They're more they're static. And so it's more like creating new input data with those buttons, even though they're right next to each other in the ribbon. And then sort of for syntax, you can think of creating measures. You generally have some type of DAX formula, and then you have some type of thing in there. Again, it's kind of like Excel. Each one's a little bit different. You just got to follow the instructions and do your best. New columns, you have this table in single quotes, and then you have the columns in brackets. And then finally, you have the table with just single quotes. If you don't have spaces in your table name, it may or may not have single quotes. But generally, I just got in the habit of doing that single quote just to get started. But that's the kind of general overview of these three things. And I want to talk about each of them, starting with new columns. And so to do that, we're going to do a quick demo, and we're going to recreate this very simple linear regression equation in Power BI. So let me jump over to here. I'm going to create a new report, some sample data. And then here, the first thing you got to do is add data as always. I have my data stored as CSVs, flat files. And so you can do this from here, but I like to go up to this little arrow guy, get data, and go to CSV. Let in, I have some demo data. And this demo data is like the data we just saw on the slide, right? Fabricated UGID, full name, freshman GPA, predicted graduation rate. So let's load that in. You can also transform and do extra stuff like that. Once we transform, we'll have kind of the data available on this side to view, but I'm going to go to this kind of data view, or I guess it's table view. And I'm going to create a new column here. You can see that just popped up right away. And if I remember that equation, it was demo data freshman GPA, right? It was times 0.6 minus 0.4, right? It's that same linear equation. Nope. What was it? Was it opposite? 4 and 6. Yes, there we go. You can kind of see that I've created the exact same number as this column. And so we can see how this number relates to each other. A couple things I think are useful just to see the live demo. Number one is that Power BI constantly gives you kind of contextual information or like contextual choices. So what I mean by that is like this whole column popped up only when I click this column. If I go back, see that's not available. And so, you know, when it works great. You can find the thing you're looking for, but when it doesn't, it's literally hidden and you can never find it. And so if you're just starting out like I was, just click as much as you can, try to find stuff and get comfortable with finding the kind of the button that you need to press in the way you do and the way that you want to do it. Because again, a lot of stuff is contextual. If I click things differently, everything shifts and moves, and usually they get it spot on, but you know, it takes time to get used to that kind of functionality. So another thing I wanted to kind of demo this is that for those of you who are more familiar with Excel, especially the table view of Excel, if you do the table, this is pretty much the same thing. Like it's the same mentality of exactly what to do. You kind of flow left to right. You do column by column and think going, okay, I'm going to take this column and then row by row, it's going to do some kind of calculation. This is I felt like a very safe place to start in terms of getting used to this sort of multi-level functionality. So I'm going to jump back to my slideshow. The next one I want to talk about quickly is also building new tables. And so to do that, I'm actually going to remake this histogram using a DAX formula. And so what is a histogram? First of all, it's grouped values of one variable, in this case, predicted graduation rate. And then you have a count of people or individuals that exist within that value, those bit group values along the y-axis. And so again, I'm going to jump back into here. The first thing I'm going to show you is the way that I first found to do this that I didn't use for this particular dashboard, but I wanted to just kind of show you I think this is the default way to do this, but if you go back to this visualization view and you right click on a variable, you can find new groups. This initially also was hidden from me because I was looking for the word bin, just because I was used to that. But in Power BI, you can do it as a group. And so once you do this, then this word bin pops up as you expect, and it gives you some defaults. But once you get that open, now we can create the actual histogram. So what I did was I clicked a visualization. Again, like a difference from Tableau is that Tableau, you have individual worksheets within collapse together into a dashboard. This is just kind of all together in one. And so I'm going to drag the bin to the x-axis, and then I'm going to drag the count of the person here And there we go. We've got this wonderful, beautiful histogram, right? And we can see this way. Second way to do this is the way I actually did it for my dashboard. And I'll kind of plant the seed for this because we're going to come back to this about why I had to do it this way. But here we can kind of demonstrate how to walk through a DAX formula. And so I'm using the formula summarize, which if you speak Excel, is basically a pivot table, right? You're creating a pivot table. If you speak SQL, it's group by with a count or some type of aggregation. If you speak R, it's aggregation. But basically, we're trying to create a table with some type of aggregate value, like a pivot table. And so now when I'm doing a new formula, I heavily depend on this kind of intelligent sense sort of guidance. And you'll see like it tells you exactly kind of individually what these things, what you've just put into each of these little sections separated by commas. This is very similar to Excel, even though it's much more powerful. So the first thing what I do is actually give it a table. And so in this case, I use data 2. And then the group by column. So again, that's the kind of the rows if you're thinking about it in pivot table language, or if you're thinking about, again, like a SQL language, it's group by. So which column are we doing the group by, which essentially is the x-axis. And so in this case, I'm doing the bins. And then you can have a second column. We're not going to have that. Or you can skip directly to the next name. And so we'll give it a count name. And then finally, we have an expression. And so this, when I'm doing a count of that value. Right. And so just again, just the tip, just try to figure out what these things mean because it's so important, especially sort of if you think back to my previous slide about the kind of shape. When I ask for a table, you got to give it a table, right? Or it's going to throw an error. If it gives you a column, you got to give it a column. This is the nature of the beast. Just making sure that you understand what exactly and translating that kind of their instructions into real world language. And so then there we have it. We have this nice little kind of histogram-based table. And it actually does create a separate table inside the data. I have one here, maybe. Yeah, this one is the aggregate. But it's literally just another table. It's just like the input data. So again, creating table is very, very flexible, and it gives you a lot of things, as a lot of tools to play with, as you'll see in a second. Going back to here, one big issue is that, as I mentioned before, these are static. If you try to give it a parameter to talk to, it doesn't work, right? A parameter is kind of a user input value. And so the real thing that really powers this on this dashboard are measures. And so we're going to talk about these 3 measures real quick. And so these 3 numbers, current students, predicted graduates, and the predicted grad rate, these are all measures. So going back to here, as I mentioned, when you're thinking in that sort of Excel table mindset, you're really thinking like column, each row does something like that. But when you're gross generalization, but when you're thinking more in measures, a lot of times you're thinking kind of, okay, aggregate, vertical. Let's collapse this thing into one kind of column. Not always, but just a stepwise kind of baby step. And so this is exactly what we're going to do for these 3. So the first one is a count. And so in this case, we're doing a count DAX function with a column. So again, we're thinking vertically. We're literally just counting each of the columns, right? And so in this case, we have 112 students because we have 1 student per row, and so we have a count of 112. The second one is we're doing a predicted number of graduates. And so the way we can do that is we can actually sum the predicted values. And so the sum, again, is just like just adding all the values in the column together, collapsing that together, and then we get 68. And then finally, we get a predicted graduation rate. And so that's the kind of chance that overall, what's the average kind of prediction graduation rate of everyone together. In that case, we can use an average. So hopefully these are kind of intuitive and kind of makes sense. We're taking that one column and we're doing kind of aggregations to it, a count, a sum, an average, and then we get these 3 measures. We're going to come back to this more, but before that, I want to jump into kind of the fun little tools to make this interactive. The first thing I think I want to talk about is slicers. And so slicers are literally one type of visualization. I think this is a really slick one. It's super accessible. It's on the visualization pane. You click that, and then you add a field right? Which is any column. And once you add that, you get this nice little kind of visual block that lets you, as the name suggests, slice the data into the way you want. So I need to move this back. And so I'm going to take and show you how this works with this histogram. And so we have the slicer, and if we change that slicer, it literally slices the data and filters out everybody who's not part of that slice. And so there you see, we have a fewer number of graduates, current students, fewer predicted graduates, and a different graduation rate, because we're literally removing some of the people from this data set. The second thing that you can use to interact, and this is a default behavior that exists in Power BI, but not in Tableau, is that you can actually click any visual, which I think is super slick. It just makes it much more dynamic, interactive. So in this case, I'm clicking that column, and it highlights that one bar here. But essentially what it does is it's a slicer for all these. It kind of filters out the data so that only this people within this column are included dynamically. And so all measures react to that. But I love how this is kind of highlighted and everything else becomes more transparent, because you can kind of see how that data still fits into the whole graph. The last thing I want to mention are filters. And so the filters, I don't love to use these very much because I find them a little bit less intuitive for people. But there is a filter sort of pane that you can engage or disengage over here in the corner. And so what that does, it brings up this kind of set of filters, and you can add data to that. You can take data away, and this is how you get to it on the actual the screen. But you can filter basically on a single visual, on an entire page, or on all pages. And so that is nice functionality. Another thing that's really nice about this is that you can do advanced filtering, where you can do kind of numerical filtering and ORs. And so again, that's a little bit more powerful than the slicers, but because it exists on its own separate pane, I actually try to steer clear of this if at all possible, just because that's something that when end users are kind of engaging with your dashboard, they may or may not see, depending on their familiarity with Power BI. Okay, so sorry, I've gone kind of quickly through all this. Next, I wanted to talk about parameters. And so what parameters are kind of the user input values. And so they're represented by those two. And to do this, we're going to actually add to our linear regression equation. And so the parameter that I chose to include was about scholarships. In this case, I'm making up the data again, so it has a perfect relationship. And so what I'm adding to the equation is this new relationship where for every $1,000 of scholarship money, there's an increase in the chance of graduating by 2%. And actually, I think I made a mistake here. I'm missing a 0 here. I just noticed. So sorry about that. But basically, what I'm adding to this relationship now is a new slider where for every $1,000 scholarship a student gets, they maybe increase their chances of graduating by about 2%. And so to get to the parameter screen, we're going to modeling, new parameter, numeric range. And then you get to this screen, which shows you kind of choices. And what it does is it creates a new table. Sorry, I just noticed there's a lot of chat here.
We are handling it, Zhen.
Okay.
We'll consolidate all the questions, and once you're done presenting, we'll ask them.
Okay, great. Sorry, I hope I'm not rambling too much. It's nice to. Okay, so to go back to here, basically in this new equation, we want this parameter interact with this new value and create, essentially what we want is a new predicted graduation rate that interacts with that parameter. And so we're going to actually have to adjust all these formulas to incorporate this new aspect of that formula. And so the way we're going to do that, we're going to focus in on this predicted graduates. So instead of sum, really, like I mentioned, we need a new graduation rate that not only has that old formula, but also includes this new scholarship parameter. And again, I just noticed that, sorry, I forgot a 0 there. Should be 0.0002, because we can't give people a 20% bump for every 1,000. If only that would be fantastic, right? So to create this new parameter, we're actually going to use a different formula, which is sum x. And so sum x, this x, is a kind of a combination of what we did with the new column as well as that aggregation overall, because it'll do a calculation like the columns left to right. I think I'm jumping ahead of myself a little bit. So sum x, that's the kind of equation. And what it does is essentially surrounds this column calculation with a sum. So I'm going to show that again. So basically what it does is it does the column thing across, and then it does the aggregation in one fell swoop. So it does two calculations in one. And so we're going to change all these formulas from count sum average to count x, sum x, and average x. So we're going to, and so when we integrate that into the formula, basically now when we're shifting this parameter, we can now adjust not only, you can adjust everything that you see here, all these measures and kind of this histogram as well, which I'll kind of talk more in a second. But you can kind of see how now that kind of plays with each other. Oh, actually, I'm going to talk about the histogram now. So for those of you who are familiar with Power BI, you might be wondering how this histogram works, because by default, these histograms don't really work with measures. And so this is my first hack that I use quite a bit to kind of deliver more complicated analytics in Power BI, but I use the switch function. And so what the switch function is essentially like a if-then statement or multiple if statements. If you speak SQL, it's a case when, it's multiple cases, but it's multiple if-thens. And so what we do is that we switch between multiple pre-calculated columns depending on the parameter. So I'm going to explain them again in more words. So in our initial histogram, table, we just had the x-axis and the y-axis. And so to make this happen, we're actually not only going to create one y-axis count, but we're going to create multiple for every single tick of the parameter. And so for the parameter, I can go from $0 to $1,000. And so with those two choices, now I need to create two columns in this histogram table. So now we have one column for the count for $0, and then one new column for a count if you give everybody $1,000. And I'll repeat that for every single tick of the parameter. So now when I make a change in that parameter setting, the histogram is it's going to change which column it pulls from. When it's 0, it'll pull from the 0 column. And when it's 6,000, it'll pull from the 6,000 column. And so, as I mentioned, it's kind of a series of if-then statements. And so in Excel or in Power BI, the if statement is basically if a criteria, you get a result. And in switch, it's basically the same thing, right? It's just the syntax is different. So switch true, and then the criteria goes first, and then the result goes next. And so this is the full equation, and it looks kind of long, but basically what it's saying is that if I make a choice in the parameter setting, pull this column of that histogram setting. And so now, and then one last thing is that if you notice before, to demonstrate, if you notice before, this histogram not only interacts with this parameter, but it also interacts with the freshman slider. And so that magic comes from this model view. And so that model view is when you connect the two bins. And so that way it automatically, like magic, just connects the data sets together. And anything that happens to one data set will also happen to the other, which is really fun and dynamic. So again, I'll just demo that again so you can see it all together. So when you kind of slice, it slices away. And then when you add, everything shifts up, thankfully, which is wonderful. It shifts up more and more, and it updates as everything goes. And so every single time this changes, this table is displaying a different column of that histogram. So that's a hack that I use quite a bit to kind of display a lot of information. For those of you who do predictive modeling, sometimes you need to move beyond a regression for certain things. One of our favorites is random forest. And so I use this switch function to kind of do non-y equals mx plus b equations. I'm able to pre-calculate a bunch and then kind of switch between them based on a parameter to give that illusion of calculation. The last hack that I want to kind of mention is comparing tables. And so again, this is something that I find very, very useful. If you'll notice, we had a resident-only section and a non-resident-only section of this dashboard, and they flow together into this combined dashboard. And so the first way to do it is not the way I did it in the dashboard, but I think it's worth exploring. So the first way you can do it, if you're only doing measures, you don't need to do any visuals. This is very handy, which is you can use measures using the calculate function. And so if you speak Excel, you probably thought of maybe I do a sum if or a count if or an average if. And so the calculate is the kind of DAX version of that. And so you have the range here, and then you have the criteria here. You can see how the blue aligns with the blue and the red aligns with the red, right? So that way you can create this sort of dynamic measure using the calculate. So that's really handy. But in our case, the one issue is that if you create multiple measures like this, and you have two different slicers, it's very difficult to have the slicer talk to only one measure, right? There's some relationship function like kind of stuff that you can mess with, but it doesn't work that well. And so the one hack, the way I do this is to simply just split the data, right? And so if a lot of times your source data comes in one big CSV or one big table. And so if you want to look at the data through one major lens, like we are here with residency, we just split the table into a non-resident and a resident table. And you can do that in Power Query, or you can do that with any kind of your Excel or whatever, however you like to kind of input the data. And so doing this allows us to then make things flow together, right? So we can have one measure here that pulls from only that resident table, and another measure here that only pulls from the non-resident table. And then we can also create measures that combine the two measures together to create that combined measure overall. And so, okay, so we covered a lot of things. I ran really quickly, but just to kind of summarize everything, overall, I mean, I hope that what you felt when we were clicking through this is that I try to create dashboards that feel more like playgrounds, right? Or scenario tools, ways that can give people ways to figure out how things relate to each other and see the results of that input very quickly. From a kind of UX UI perspective, I just try to give people stuff to click as much as possible, right? I just really love these sliders. I think it's very intuitive. I love how these things talk to each other by clicks. I just want to give people things that they can click on. From a math perspective, really, this is just a ton of algebra. All right, it's just making sure that all the algebra happens step by step in the right way, and that you get the right metrics flowing together and the right kind of confluence of things to give you something that kind of builds to potentially more than some of its parts. And so today, I went back. But just to cover, we talked about the histograms, new columns, new tables, and we talked about the measures, slicers, selection, filters, parameter measures, and then these two hacks, which are the switch function and pre-dividing things into groups. And so now that is the end of my presentation. I look forward to hearing from everyone, and I hope to see more of the dashboards that you all create. And if you have any questions at any point, I'd love to interact. Here's my email here, and find me on the Meetup or LinkedIn or wherever. But thanks so much. I'll kick it back to Jeff and Pete.
Yeah, thanks, Zhen. We've had a lot of questions in the chat. So I'll start the discussion with one of the first questions. This came from Jennifer. She was curious how you fabricated the data.
I like to program in R, and so I just use that. I just did random number generators. And then as I mentioned, the model she created is 100% accuracy. I literally worked backwards. I created the formula first, and I extrapolated the freshman GPAs. But obviously, if you're really doing this kind of analysis, you'd be starting from the input data and then trying to figure out the relationships themselves. I think with regression is a really great entry point because I personally find it visual, right? If the data looks like a line, probably a line, right? You can kind of extrapolate the line from you put a line in best fit. A lot of times it looks more like a curve. You use a curve equation. Again, I also mentioned we like to use random forest a lot. They tend to be more accurate for the questions that we have, generally because we have kind of categorical outcomes, like a yes or a no. And random forests and decision trees, they basically bucket people into yeses and nos. And so I think the math pairs very well, and that plays out in accuracy measures as well. And so that kind of, yeah, you can do it in a variety of ways. But I personally, I use R. There's a package to just create names. Those are all fabricated names. And I just did random number generators for everything else, like the UGIDs. I just find that it's nice to see something more tangible. It just looks more real, and hopefully it feels real when we're playing with it.
Yeah, very much. I've used Python to create mock-up data. And the great thing about using R and Python is that if you go into Power Query, you can just paste your R script or your Python script into Power Query. Just have Power Query run it and generate the data for you, and then it loads directly into your Power BI data model without having to do anything else. It's pretty good shortcut whenever you need to mock up some data. Another tool you might consider if you need to mock up data is Mockaroo, I believe it's called, which you can actually give it a little more specific like schema that you want to generate and so on. So Heather was asking, why did you create a many-to-many relationship in your model?
Because in that type of data, well, first of all, it defaulted to many. It's just the nature of the data has to be many to many because no, when you have one to many, you're really connecting the primary key to another to something else. In this case, I'm not. I'm connecting kind of ancillary data, kind of supporting data to another piece of supporting data. In this case, it was the bin, the group that they fit into when you talk about the prediction, their predicted outcome. And so I'm really kind of, if you can imagine, it's one row per student, but each student has a different prediction point. And so because that can vary, and a lot of people can actually have the same predicted outcome, ideally 100%, right? We want everyone to graduate. If there were a bunch of people with 100%, then that's many. And then the other table, you have many because you have that 100%. You got to connect it that way. So I hope that clarifies that.
Yeah, I believe so. We are getting some questions from folks. If you would be willing to share the dashboard so they can create their own fake data and get a better understanding of how it would turn out for them. Would you be willing to share your PBIX file with people?
Absolutely. Yeah, I'm happy to share. I think I sent you that file a little bit earlier to be.
Yeah, I think you sent it a few days ago. And your slide deck too, would you be willing to share your slide deck as well?
Sure, absolutely. Happy to.
Awesome. So yeah, if you're interested in getting the slide deck or the PBIX file that Zhen has used today, I will circulate those through meetup.com best way I can. Let's see. There's been a lot of discussion about everything under the sun. I'll invite anyone, actually, if you have a question for Zhen, to unmute yourself and pose the question to the group, if you have one.
Hi, Zen. This is Christina. I have a question for you, and it may be because I'm not really familiar with R. Have you created the regression model in R? Am I understanding that correctly? Or did you paste that into Power Query? Am I getting that correctly?
Yeah.
Thank you.
So R is kind of a statistical programming package. Sometimes it's just it's basically a programming language, but it just it's object oriented, so you kind of like save different files, and you can just do a little bit more math in it. Basically, what I did to generate this was I because the regression formula is based on that y equals mx plus b math, I literally just did y equals mx plus b backwards to create the input file. So I can share my screen again in Power BI. Basically, when I was talking about using R to create the file, I literally meant this. Like I literally, this was what I created. So this is a, like it was a CSV file or an Excel file. You can export in the same way, but this is literally exactly, I just created all these numbers fake, right? So these numbers are all made up. This is using a package, which is kind of a pre-made program that just gives you random names, because I just like that and how it looks to have actual names, even though they're not real. This is as a random number between, I think it was like 1.8 to 4, just a random number to create that. I think I did skew it more to the positive side because I wanted to be positive and have more of my students graduate. And then, again, I just did random numbers for these things as well. Like I wanted first gen. So these are all just random numbers. I
Thank
think
you.
if
And
that
for the
clarifies.
names, oh,
Yeah.
I'm sorry. Thank
Okay.
you. And for the names, you said that you use some package. Is that package available in R?
Yeah, I think so.
Okay, thank you.
If it's not too, this is what it looks like in R. It's a coding thing, and so it just. Oh,
Yeah.
I didn't do it here, but it was in like a names package. If you'd like, I can send that to you.
Yes, thank you.
Yeah, or I think I just Googled it. I think it
That's
was.
all my questions. Thank you so much, Zhen. I
Yes,
enjoyed your.
absolutely.
I'll add that you can use DAX for linear regression in Power BI. You could use Power Query. You can use Python and R scripts embedded in Power Query, or you can do Python and R visuals that are embedded in the Power BI report itself. There's a lot of different ways that you could solve that problem. Bill is asking, how about using Power BI to correlate GPA with success in the job market? Have you done this kind of analysis before?
Yeah, we have. Generally, we don't use Power BI to actually do the analysis because it's more restrictive. It doesn't have it's not really made for that, I don't think. I think it's amazing at displaying information in a dynamic way, which is what we use it for. But yes, we do like career outcome analyses, and again, like I mentioned, we use random forest a lot for that because it seems to be better. Um, we're lucky at UGA to have pretty successful students. A lot of times it's the issue is like it's a needle in the haystack really issue where we have to do a lot of analysis to try to like shift and find the students who have potentially more trouble. And so that's the kind of mindset we take, but that's the kind of that's the kind of the work that we do. It's like I think I start at the end, right? Generating the actual equation and predictive model is very difficult. Like in terms of actually running the function, like if you write R or any language, any language can do it. Python, R, Stata, anything really that you want to use, they all can generate models. But once you get that, that's the point at which you can use Power BI to kind of display that in a unique way. Because a lot of times I think for senior administrators, it may not be completely clear why you would even want a predictive model. And I think this makes it more real to be able to click and see, okay, this student has a 90% chance. Like, oh, I get it. Like it just makes it much more tangible in terms of why these things are powerful.
Emil is wondering if it would be possible for you to share your R script as well.
Yeah, I'll have to find. I forget where I got I guess because I just pulled up that script. I didn't have that names function. But yeah, yeah, sure. It's just algebra. It's like it's just. But yeah, I'd be happy to.
All right. Another question is, how are you syncing your SQL Server on-premises data with the Power BI service? Are you using the on-premises data gateway up to your workspaces?
Yes. There are some dashboards we use where we need that up-to-date data. We generally just do CSVs just because we have to do so much analysis prior to it. So for like dashboards like the one you just saw, it doesn't really change that often, maybe once a semester. And so we'll pull the data into R, like kind of if you think back to that one slide where I was doing the arrows between, we literally pull it into R, we do the analysis, and then we spit out a number and we put it into Power BI. And we just update that whenever it's asked for. But there are a couple dashboards where we do use the actual functionality, because it does have, like you mentioned, Pete, like Power BI can talk to all these services. And so all we need to do is just put our server name and allow it to kind of pull data, and then it can just refresh as often as you'd like. So it's very, very flexible.
Yeah. It might help us at some point if we actually did a demonstration of how to work with the on-premises data gateways for those of you who have Oracle or SQL Server on-prem databases. That's something that I can walk us through in a future meetup. Another thing I'll say is, Zen, you brought up something that's really important for people to understand. There are so many different ways to bring data into Power BI. Like you don't have to, like you do have to use Power Query to some extent, but you don't have to actually use Power Query to do all of the connection and transformation. You can, Rhonda Belton from Elon is on the call. She uses SAS for a lot of her data preparation. People use R, people use Python, people use Power Query, or the data may already be transformed at the database level or the data warehouse level, like it may already be inside of a dimensional model in a data warehouse. So there are a lot of different ways that you can do the transformation and data preparation. There's no one size fits all approach. And so pointing out that, Zen, you've used R primarily to do a lot of that work up front is just important to illustrate that fact about Power BI.
Absolutely. And just to add that a little bit, I always try to think about it in terms of just raw data, and a lot of times it's math. So just to I wanted to give that linear regression explanation just because you can see how that was the very simple math. In reality, when we pull in something, all this data is this is all fake, but all this data would be, it's just from the source system. And what we're using the R for is really just generate this one column, right? That's all, because it's a static number that we generate from our model. Hopefully it's more accurate than that's the most accurate number, but this is literally the only number we need to bring in. That's the thing that powers this whole dashboard. And so, again, just to build on top of what Pete's saying, hey, whatever it takes to get this number, right? You can do it. If you need to type it in with a calculator, whatever you need, as long as you get this one number, then Power BI is happy, and then you can do everything else. And again, when I think of Power BI and from a math perspective, I really am thinking about a lot of algebra. Like everything is algebra. It's like this is algebra. It's just a summing of all the whole column, right? That's just the input is the column. So if you change the input, you can change this number. Right. And so in these two cases, it kind of illustrates how this same formula creates two different things depending on the input data. And again, everything else that comes together, depending on how you slice it, is all just kind of algebra. And so regression is a much more complicated formula. Random forest is a much more complicated math. And so that's why we wouldn't do that in Power BI, because it's not really made to do math. It's really made to display information. And so Power Query can do those things, or whatever it takes. I think for us, in our data science mindset, we don't really care as much. It's really, we just, whatever it takes to get that number, where we'll do it.
Yeah. Emil gets bonus points for today because he cited what's known as Roach's maxim. Matthew Roach is a Microsoft employee, and he's been involved in the Power BI platform for several years. And he has a maxim which states that your data should be transformed as far upstream as possible and only as far downstream as necessary, which the translation is to try to do your data transformation as close to the source as you can. So as close to the source data, and that could be a data warehouse or, somewhere along those lines, but, generally try to avoid doing data transformations far downstream, like in the Power BI report, because at that point you're getting away from the idea of having consolidated business logic in one area, and you run the risk of maybe calculating something differently than the way someone else calculates it in a different office at your college or university. So definitely keeping Roach's maxim in your mind when you're working with Power BI. Do your data transformation as far upstream as you can and only as far downstream as you have to. Got another question. How do you configure Power BI gateway service if your organization has a firewall? You go and it blocks the connection to Power BI service. So, yeah, it brings up, you have to collaborate with your network team. But yeah, setting up Power BI gateway is usually fairly simple, but you will have to sort of work with your infrastructure team to figure out sort of inbound, outbound IP addresses and so forth. and configuring all of that in Microsoft Azure. But once you get that figured out, honestly, keeping an on-premises data gateway running in Power BI is pretty simple. Like the way we do it at Davidson, we have 2 virtual machines that we run, and the gateway is installed on both of those machines. And it just runs 24/7, 365. We'll do updates every now and then, but those VMs, that pair of VMs is a gateway cluster, and that allows our Power BI cloud to communicate with our on-premises SQL Server and Oracle environments. So there's a little bit of network involved, like making sure that those VMs, can communicate with those on-premises databases, whether they're on the same subnet or a different subnet, and just making sure that those lines of communication are open. But then once you've got everything worked out, keeping the gateway running is really just a matter of making sure the VMs are running. It's a very powerful tool for connecting your on-prem data sources to the Power BI cloud. We're at 2:05. Does anyone else have questions?
I think one question Megal asks about how do you learn all these functions and asking what they do. Well, I think the first thing you gotta do is kind of dream up the best way to represent data. I think that's always the mindset we take, because at the end, when you get to the Power BI step, you really think about presenting data. That's it. Like that's the mindset you take. How do we explain this as simple as possible? And then for me, I do it once on paper, and then I try to replicate that using Power BI. So again, like based in my mindset, again, I think of Power BI as an algebra engine. If I can do it in algebra, I can do it in Power BI. I just got to figure out how to do it. It's just, well, generally speaking, you can do it in Power BI. So it's kind of like, I try to work backwards, right? I can imagine a dynamic histogram. How do I make this work? Right? It's kind of that kind of mindset. I know how to calculate a predicted graduation rate based on this model. How do I do that in Power BI? Right? It's just trying to work backwards and figure out what is the thing that you're trying to communicate, and then just Google everything else. If you're stumbling over something like a DAX formula, just search the DAX formula. Try to understand what each step is going through. It's just kind of like learning Excel. Like you got to do exactly what they say, or it's not going to work.
Yeah. A lot of YouTube videos out there that can be useful for learning DAX. Our July meetup, we're going to look into the foundations of DAX with Tom Martins. That should be a very educational session because he's going to go into some of the things that makes DAX really tricky to learn and explain it in such a way that hopefully, you'll be able to get over that, because a lot of people just sort of go into DAX assuming that it's kind of like Excel as a formula language, but it's way more complicated than that. And there's a point, a lot of people sort of run into just a brick wall with DAX where they can't quite figure out how to really make it do what they need it to do. And they get frustrated and give up. And I totally understand why. DAX is a very unforgiving language, but when you understand things like filter contexts and how the calculate function works and how you can use variables in your DAX, it becomes a lot easier to get over that hump. But that's why I strongly encourage coming to the July meetup, because I think Tom's going to do a very good job of explaining some of the mystical properties of DAX that people really have a hard time with. I do a terrible job of explaining it, but I think Tom will probably be a much better instructor. All right, last call for questions. Yeah, Emil brings up a good point that, one of the reasons DAX is so hard to wrap your mind around is because it sees things in terms of tables. It's like, I don't know it's like Excel formulas are checkers, and DAX and Power BI is like chess. Like you have to think in a lot of different areas. So Jonathan asks, what what should be my rationale to decide when to use DAX as opposed to using Python? Um, well,
I
I
think
think that, go ahead,
I
Sid.
can, yeah. I think for me, the choice is kind of um, how much. So it's kind of driven by two things. Number one is how much math I want to do, and number two is what kind of output I want. Right. So if my output I want is like a number, like I was mentioning that one column, then most likely Python will be the right choice. If my output I want is an interactive dashboard that I want people to use and click on and share widely, then that's definitely Power BI. So Python, of course, can do that as well. You can create lots of wonderful visuals, but just because people get used to one dashboarding software, find it helps to just stick with the dashboarding software a lot of times. So
Yeah.
like when like we also create like our a lot of kind of we use a lot of like R tab tables. We use Quarto documents and different types of interactive things as well. But again, like people don't find it as intuitive as Power BI. So generally speaking, that's kind of the mindset I take. Again, in terms of the math, like again, I think of Power BI as like a algebra engine. If it's anything beyond algebra, like I'm trying to like again fit a little regression line or to like figure out which variables talk to another one or massive like correlation table or any type of more complicated math, then like automatically you just have to use Python or R, because you just can't do it in Power BI. It would be so difficult to kind of. A lot of times it's even easier. Like once you get it done once, you can kind of use the R tools that P has mentioned, like the and not R tools, but those tools that P has mentioned in Power Query to kind of run the scripts and update things. But again, you really don't want to be writing it in those systems because just asking for a lot of pain. Yeah, as to that. Hopefully that helps.
Yeah. So, so the idea of doing your calculations in Python and then putting that output into your data model, you can visualize that and you can visualize that interactively. However, what you've done is you've created what's known in the Power BI world as an implicit measure, which is different from an explicit measure. An explicit measure is one that is defined in the DAX formula language in your Power BI data model. And using explicit measures gives you a lot of advantages over using implicit measures. Number one, explicit measures are a lot more flexible. With implicit measures, you only have a handful of ways that you can aggregate that data, and it's basic stuff. It's like count, distinct count, summing, averaging, median, that kind of stuff. With DAX, you can be a lot more specific and a lot more complex with the kind of calculations that you do, which gives you an edge for sure. Number two, explicit measures in DAX can be reused by other measures. So you can create what is basically nested measures. You could have a sum measure that sums a column in your data model, and then you can have measures that are downstream of that that apply different logic to that sum measure. And the way I've used that a lot is in some of our financial data models here at Davidson. You can create a measure that sums up your transaction amount column, but then you might have another measure that gets all of the debit transactions and all of the credit transactions, or you might get all of your expenses and your revenue or your compensation. So you can use DAX to break that down a lot more, and it gives you a lot more flexibility with how you visualize your data, how you calculate it. I put an article in the chat to check out from Radicad, which is one of the biggest, most well-known names in the Power BI world, that kind of goes into the difference between explicit and implicit measures and why it is considered best practice to use DAX for doing those kinds of calculations. All right. Well, this is a really good discussion. I really appreciate the questions from everyone. And I sort of took over the Q&A portion. Jeff, you want to
Now,
add anything before we break up?
I was going to say it's really great to see folks engaging in the chat and the conversation. I mean, this is what their user group's about. So, no question is a quote unquote dumb question. All questions are equally valuable and everybody learns here. So, I mean, I learned I learned a good bit today. I think it's really good to see the what you created, Zen, in terms of the interactivity, but also to answer these what ifs. What ifs are extremely powerful, especially when you're dealing with leadership, right? In order to make decisions. So hopefully everybody took away some valuable things about how they can create some of those what ifs there. I know internally for UM, and Jen put it in the chat, but we've used field parameters on a few of our reports, and they've obviously been very helpful creating that dynamic nature for the report, right? The user can go in, slice and dice by whatever they like. But numeric parameters, really, we haven't used too often because a lot of our what ifs have been done in Excel, but not scalable, at least not as scalable when it comes to Power BI, right? So something that I think, Jen, if you're still on, hint, hint, we're going to have to start looking into that a little more for UM. Oh, yes, she's on. Okay, good.
Yeah, thanks again, Zen. This was great. I especially appreciate sort of seeing this from the perspective of a Tableau user and comparing the two platforms. I think that that resonates with a lot of these people. I know we've got at least one institution here in North Carolina who we've got some folks attending from there for the first time because they heard about this talk that you were giving and they're about to move from Tableau to Power BI and really wanted to hear what you had to say. So again, really appreciate the excellent presentation. To everyone, I will send out a message on Meetup with the link to the survey, the May 2024 feature summary for Power BI, RSVP links for our upcoming meetings, and I'm going to try to find a way to attach Zen's PBIX file, his slide deck, and the R script, right? So.
Yes, no, thanks so much for having me. This is great. I'm glad. I hope that people really, get. I think this is a great community that you're building here, and I'm excited to contribute, a little bit to it.
Thanks.
Thanks, Zen.
Well, thanks everyone. Appreciate all the feedback. Appreciate all the engagement, and we will see you at the next one.
Bye, everybody.
Bye, everyone.
Thanks, everybody. Have a great day.
Thank you.
Thank you, everybody. Bye.